So this is just a short video after noticing some of the problems not getting factored correctly on how to factor one of these product rule, chain rule with rational exponents. So I've done the answer already, at least by the product rule and chain rule, and this is what we get after taking the derivative of what's in blue. So what I want to concentrate on here is how to factor this so you can find when this thing has horizontal tangents. So the first thing to go for is the numbers. You do it kind of piece by piece. So the numbers that we have are 12, or coefficients if you want to call them, and 4/3. So there's two parts to this. There's the numerator and the denominator. The numerator is usually the easier part. Remember, 12 is over 1. And 12 and 4 only have 4 in common. So definitely I'm going to pull out a 4. But then you have to look at the denominator. And if 12 had a denominator like a 5, then I would be saying something like common denominator of 5 and 3 being 15. But since this denominator only has 3, I'm definitely going to kick it out. So if it was 12 over 5, I would actually put a 15 under the 4 and then do what I'm going to do next. All right, so after the numbers come anything that's in common otherwise. So we have here 4x plus 9 and 4x plus 9. And then you have to look at the powers and pull out the smaller of the two. The square is actually the smaller one. So then this becomes 4x plus 9 raised to the second as a greatest common factor. All right, next up is 3x plus 4 and 3x plus 4. So when you're talking about smaller powers, you have to take into account negative numbers. 4 nines is definitely smaller than a positive 5 nines, but because 5 nines is negative, he actually becomes the smaller one. So we're going to pull out 3x plus 4. Oops, I didn't change the color. 3x plus 4 raised to the negative 5 nines. All right, now that we have the greatest common factor pulled out, what's left behind is left behind by division. So I'm just going to do this one piece at a time. So the first thing I'm going to divide by is 4/3 into both of the coefficients. So the first one will be 12 divided by 4/3. And that's the same thing as 12 times 3/4, which is the same thing as 9. So the first number I'm going to get left behind is when I divide 4/3 into 12, and that gives me 9. The next one we're going to divide by is this 4x plus 9 all squared. So the term up here is already 4x plus 9 all squared, so that just becomes 1. And then we have to divide 3x plus 4 raised to the 4 nines by this 3x plus 4 raised to the negative 5 nines. Now they have the same base, so the only thing we have to do is subtract the exponents. So off to the side, 4 nines minus a negative 5 nines, better known as 4 nines plus 5 nines, better known as 9 nines or 1. So that's going to leave me behind a base of 3x plus 4 raised to the first power. All right, so that takes care of this first term. When we pull the greatest common factor out of the first term, we're left with 9 times 3x plus 4. All right, and then we have this plus sign, so I'm not going to change that. Leave that there. And then I have 4/3 divided by 4/3. Obviously, that's going to be 1. And then I'll have 4x plus 9 squared dividing into 4x plus 9 to the third. So when I subtract the exponents there, I'm going to be just left with a factor of 4x plus 9 to the first power. And then lastly, we're going to divide the 3x plus 4 to the negative 5 nines, and this is exactly the same, so that's going to leave me a 1. Oops, change the color there. Blue. All right, so that is what's left behind after pulling out the greatest common factor. So the last step is just combining like terms, getting rid of the parentheses, and seeing if there's any more common factors. So we have 4/3, 4x plus 9 squared, 3x plus 4 raised to the negative 5 nines, times Distribute the 9, we get 18x plus 36. I'm sorry, not 18x. What am I, crazy? That's 27x raised plus 36. And then here we're just going to get 4x plus 9. All right. So that'll leave us 4/3, 4x plus 9 raised to the second power, 3x plus 4 raised to the negative 5/9. And then in here we're going to have, what's that, 31x? And I'm doubting that there's going to be a common factor, plus 45. Because 31 is, I think it's prime. Okay. Well, at least it's prime of 45. So if I did have to set this equal to 0 to find horizontal asymptotes, I would set the following equal to 0. This factor equal to 0, which basically you can ignore the square and you'll get the answer negative 9/4. This factor equal to 0, you'll get negative 45/32. But this one I cannot set equal to 0 because it's in the denominator because the power is negative. So be really careful of that in the next section. But that is factored form. Now Mobius wants it where parentheses are around each individual factor. Let me back up a little bit here to get rid of all this writing. So it wants parentheses around each individual factor and a time sign in between each factor.